Hobson, and I run a YouTube channel called The Hacksmith, where we take fictional ideas from movies, comics, and video games and try and make real working prototypes. So one of my very first projects I did was actually made a pair of Wolverine claws, and that was a good 4 years ago now, and that was just for a Halloween costume. And after I made those, I was like, man, this is kind of cool. What else could I make from movies? And that kind of just spiraled from there. So quite often, we base stuff off of big blockbuster movies. So for example, one of our most recent projects was a Captain America shield, complete with an electromagnetic bracer, which allowed us to attract it from short distances and throw it around just like in the movies. Which is pretty cool because in the movie, it was 99% CGI, and here we actually made a real shield that actually did what it did in the movies.
170 pounds. Like nothing.
So one of my very first projects was building a pneumatic-based exoskeleton off of the movie Elysium.
It did not feel like I was lifting 170 pounds. I was helping a bit, but that's because my air compressor only does 125 psi. These cylinders are actually rated for 250 psi, which means if I upgrade my air compressor, I could potentially curl around 300 pounds. But I don't think my back or legs will take 300 pounds like that, so I'm going to have to build the lower half exoskeleton. Alright, can we get a countdown?
3, 2, 1. Here it goes, here it goes.
I've been working on a few Iron Man related projects, and one of the most recent ones, which I'm working on right now, is trying to build an Iron Man flight system.
As it turns out, if we strap any more rockets to my body, technically we're breaking some laws, and unfortunately, I'm not actually Iron Man, and I'm not above the law. So, in the interest of keeping this project going, we've decided to do something a lot better. Hobby King has joined us, and they're sponsoring the project with electric ducted fans.
So we're actually using electric ducted fans, which are used in RC planes, and basically they look like mini jet turbines, and they can produce a lot of thrust, but they're still fairly large. So again, it's not going to be quite as compact as the Iron Man suit, but the plan is a fairly small suit, jetpack. One's mounted on your wrists and legs, and then you'll be able to fly around like Iron Man. I studied mechanical engineering at Conestoga College, and I have a Bachelor of Engineering from there. My first job was at a company called Athena Automation, where I did machine design. After that, I moved back to the area and started working for Christie Digital, which is where I designed digital projectors. During that time, I was running my YouTube channel on the side and working on small projects here and there. And then, almost a year ago now, I actually quit my full-time job to focus on YouTube full-time and put more time and effort into these projects, and it's been working. The channel's been growing massively. We're almost at 700,000 subscribers right now, and we're hoping to crack 1 million before Christmas.
Alright, so the setup of the Taz 5 was incredibly simple. I think it probably only took us about 5 minutes before we had it hooked it up to the computer and starting to print our first test octopus. But it seems to be printing fine, so we're going to move on to an actual proper part that we need for the Iron Man Flight System Mark II. It's a bracket for our EDF. Alright, so we got our first 3D printed part off the Taz 5, and we've already redesigned it and started printing a new one.
So I actually got my first 3D printer around 3 years ago, and it was probably within the past 5 years that consumer 3D printers have started to be available, and they can range from a couple $100 to a few thousand. It was kind of a bit of a fad. A lot of people were like, ooh, 3D printers, and everyone rushed out and bought cheap 3D printers and then got crappy parts printed. In recent years, it's really, the market's gotten a lot more mature, and you can get consumer grade 3D printers for a few $1,000s, which can pretty much keep up with industrial grade 3D printers, which cost more like $50,000 to $100,000, which is awesome. For us, it's extremely useful because it allows us to prototype our ideas and refine those ideas multiple times before we make the final product. And having the 3D printer in the shop allows us to be able to do that. And the neat thing is, a lot of people think, well, you can only use 3D printing for prototyping. They're not going to be strong enough to use for an actual thing. But really, it's all about how you design the part and what you're using it for. So for example, the Iron Man flight system, a lot of the parts we're using on it are going to be 3D printed right here. And a lot of people are like, no, you can't do that. And the truth is you can, because they're all smaller parts in a bigger system. And they don't need to be steel or aluminum, they don't need to be metal parts, as long as you design it with the material in mind, which is plastic. Personally, I love Kitchener, I love what it's becoming. Some people call it the Silicon Valley of the North. Apparently right now we're the second most startups per capita in the world, just behind San Francisco, which I think is pretty cool. And with the innovation district in downtown Kitchener and Velocity and Communitech and all that, it's really quite cool. And my card's at Velocity and whatnot, and I've actually helped quite a few startups because I have laser cutters and 3D printers and whatnot here. So it's kind of cool to be able to do a bit of consulting on the side and seeing all these companies coming together, and I think it's going to be a lot of really cool stuff coming out of the city. So in addition to being a grappling hook, it can also lock onto objects. In order to really push the envelope with innovating, you have to focus on innovating anything you want, basically. So for example, all the stuff I do, the Make It Real projects, there's some really cool stuff, but it's probably not commercially viable, which means no company is going to make this product because no one's going to buy it, or if they are, it's going to cost way too much money. But the way I see it is, just because it's not commercially viable doesn't mean someone shouldn't try and invent it and show you that it can exist. And I think that's very inspiring for a lot of people. And we receive hundreds of messages from youth around the world telling us how we've inspired them to go into engineering technology, and really that's reward in itself.